So the sovereign data and SSI beyond blockchain. So um, it's interesting thing that in a space of ownership, blockchains made the revolution for sure. We have no questions. With the tokenization, you get the tokens that you could own, and it's super cool. But it's a old problem that I was talking for a long time. That blockchains have a couple of problems. So the first problem that any kind of blockchain focus on the replicated decentralized state that are global, and the global state is hard to achieve because to achieve the global state you need some protocols to synchronize all the things, and it's usually slow, and it's usually quite expensive, and not always you need a global state. And another problem that appear in the blockchains that this state is not just global, this state is public to everybody. So it solved the millions of the use cases. So the blockchains are super useful. When you need the transparency, for sure the blockchain could help. But the speed, amount of transactions that blockchains could handle, and the price sometimes make them not available for all our use cases that we have. And if we accept that we have some global blockchain that everybody use and everybody agree, maybe it's super cool, as we have with the Bitcoin, that Bitcoin was the first network, and it was clear that you have your private key, you have your public address, and everybody knows that if you're talking about the blockchain, it's the Bitcoin blockchain. But it's not true in our modern world. Right now we have a huge amount of the blockchains of the different generations, of the different features. There's so huge amount of the different networks that right now you have the same problem as in a modern internet, that you have the fragmentation of your identity, and you could not host the different assets between the different blockchains and make them interoperable. So somehow blockchains lock you in a network, and if you want to do something, it should happen inside the network. And for example, even Ethereum with the smart contracts create the problem that if you need something from external world, you could not have it. And then we start inventing some oracles and some other things that allow us to interact with the external world, and still the global state is the problem. And what could be the solution for more private and maybe not so global state? Maybe we care to share the state between the people that are involved, or maybe we care to share a state privately with the people that we want to share. And to build such kind of privacy focused networks, this still could have the decentralized solution, but on practical, user do not care if it's decentralized or not. User more care if it's sovereign, and if he could make his operation on his own. And here we get to the point where we still want to have a decentralization, but in slightly different way that blockchains offer to us. So we still want to have the ability to have a network of the independent entities and independent agents. You want to make this network open to everybody, so everybody could participate. We still want to have the ability to identify each other, and here the self-sovereign identity came to play, because one of the big building blocks of the self-sovereign identity actually is the DID, decentralized identifiers. So you have some kind of identifier that help you distribute your private and public keys, because we still heavily rely on signatures and cryptography to verify the ownership of something. Yeah, so you need to sign something to prove that you are the owner of some action or transactions or some other things. But right now we don't have a network anymore. So we don't have some global addressable space where you could use the public key as an address, because network doesn't exist. And maybe this network could be eventually composed by the agents that have the common interest. So we don't have some kind of global registry. And without the global registry, we need to have a way to distribute our public keys. And actually the DID help us to do it. So you have this URL like identifier that have the rules how to exchange the identifier to the public key, and now you could validate the signature. Super cool. And it's completely abstract. So it's not dictate what kind of cryptography you could use. It's annotate what kind of cryptography was used for this key. So maybe you will have some complex schemas of threshold signatures, for example, and some other things that actually simply not possible right now with the blockchain eclipticers and all other things. Maybe you have some more complex cryptography that could address the group interactions and so on. So with the DID it's possible, because DID is a cryptography mechanism agnostic, and DID just care to distribute your public key. With the distribution of the public key, right now we have ability to identify yourself. Also, the alternative actually way, it's the programmable signatures. Yeah, so you could distribute not the documents with the public keys, but you could distribute some zero knowledge proof circuits, but it's a topic for our next video. So now you have the DIDs, and it's super cool. But what happens with the state? Yeah, for example, what happens with something like transactions and the data points, how we could share them in a network. And here to play we get the next instrument that's in a self-sovereign identity called the verifiable credential. Yeah, so verifiable credential give us the authenticity of the data, because we could form the data, we could distribute together with the data the JSON LD context that explain the meaning of the data, and it's already much more interoperable than the smart contracts. And the next thing, together with the context of the data, you share the signature and the DID. So you have all abilities to validate if this data point belongs to a certain person, if it's authentic, if it's not changed. So we have the way of distribute the data points as tamper-proof crypto documents. And these crypto-proof documents are actually the building blocks of the more complex protocols that contribute to the data exchange. And here the most interesting things happen, that right now you have completely decentralized system that able to exchange the data. And now you could build on top the more higher order protocols that will involve some kind of the trust tasks and some kind of incentives and all other things. So you could build the e-commerce protocols, you could build social network protocols, you could build all other things. And the protocol network is a completely separate story. We should talk about the protocol network separately, but right now, just with two simple instruments like the decentralized identifier that distribute your public keys and the VCs, you're already able to build actually decentralized system that exchange the data. And we could make one step further, that instead of the DID and your public and private key, you could build the protocols that focused on the attributes and the data points. So we say that not the owner of the public key or private key, but the owner of this particular VC with this particular data points that able to prove the ownership of the VC could do something. And here we get to play the last piece of the verifiable credentials and SSI, the verifiable presentations. Yeah, so if I could prove that this VC belongs to me, then I don't need some complex things, because now I have completely data-driven and data-based exchange protocols, where even the signatures are not so critical anymore. So we're not so focused on the particular key, we focused more on the data, and this data abstraction on top give us much easier and more straightforward way to build the organizational collective ownership of the data points. Because right now, instead of threshold signatures and some complex cryptography, you just share the data points that could be in a collective ownership. So it's much easier and much simpler than we think before. That's why the self-sovereign identity is beyond on the blockchains in a decentralized world, but still SSI in many cases need a blockchain to operate. But we will discuss this in my future videos. So choose.